Just take a second to read it and absorb it. It says, assume the probability that a child is female is a half. Sex is independent from child to child. Just pause for a moment. Just in that one sentence, right? What's been ticked off here in that list? Two options per event. Boy, girl. Identical events. What language? It didn't say identical. What was the language that told you? Independent from child to child. So that means every time you go again, which by the way is not strictly true, sort of, we're treating that as a whole new event, which is exactly the same as the previous one. Okay. Giving your answers as fractions in simplest form, find the probability that in a family of 5 children. Okay. What was the last criteria that I used? Many stage. And when did I tick it off? Just now, when I said 5 children, okay? So, I mean, it is physically possible to draw out this tree. How many options will it have? What's the sample space? 32. I mean, 32, right? 32 total options. And I can actually list out some of these, and I will in a second, not all of them, but enough just to get a sense of what's going on, okay? Now we're asked, find the probability that in a family of 5 children, and then here are all these particular situations, okay? So let's just start with the easy ones. This is question 1, part A. Because of the way this particular question is phrased, the first one, no fancy techniques are required, right? What's the probability that every single one of the children is a boy? Now, remember I told you, this thing is going to be hard to draw, so I'm not going to draw it. But the first option is a very, very simple part of this tree, right? If I've got, say, boy and girl, etc. How many of these 32 options is eventually going to be useful to me? Only one of them, right? It's this one over here that's going to follow all the boys along here, right? So therefore, the probability of 5 boys is going to be a half, and I've got to do it 5 times, right? It's the power of 5. Yep. That gives me 1 over 32. By the way, you'll notice there's a gap there. There's a reason for that. I'll explain it shortly. Okay, have a look at the next part. Part B. What's it asking? There are 2 girls and 3 boys. 2 girls and 3 boys. Okay, this starts to become a little bit trickier, right? It starts to become a little bit trickier. I'm now going to start to list some of these options out, right? Maybe you want to put this off onto the side with a different color. This option that I've already answered a question about, 5 boys, it looks like this. Boy, 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 boy. Okay? Now, if I want to do this in a kind of systematic way, this is 5 boys, right? This next one is about having 3 boys. That case is a bit trickier for me. Before I do that, I'm going to do 4 boys. It's actually a lot easier. So this is 5 boys. What kind of options are there for having 4 boys? I'm just trying to do this step by step. Well, you could have 4 boys, 1, 2, 3, 4, and then you have a girl, right? Or maybe you have 3 boys, then you have a girl, but you've got to stay with 4 boys, right? So you finish off, right? Can you see I'm trying to list this out in a systematic way? What are the other ways? Well, maybe I should ask, how many other ways are there? There are 3 more, right? I could have the girl in the middle, boys either side. I could have the girl second, or I could have the girl first. This is all the ways of having 4 boys. Does that make sense? Okay, now you can see there's one way of doing this. There are 5 ways of doing this. When I keep these all together, right, and I say there are 5 ways in total, do I care about their order? Do I care about their order when I say there are 5 ways?
Yes. Yeah.
So the way I've listed them, right? I have kept order. But when I say, okay, 5 in total, right? Now I'm like, okay, forget where they are. I just know there are 5 of them. And wherever it is, it's no big deal, okay? Which is why, what is the number? Remember, we're under this, right? What's the number that gives me 5 out of this? This is actually 5C1 for one girl. Or if you like, I could have said it's 5C4 for 4 boys, because of course it's symmetrical, right? What about this one? Same thing viewed from both sides, okay? Which is why, by the way, I left a gap up there. That gap is for the fact that this is actually 5 0. That's how many ways you can get 5 boys. There's only one way, right? Okay, so now I'm ready to answer this next question. I'm not going to list it out because you can already tell me how many there will be, right? It won't be 1, it won't be 5, it'll be 10, because that's 5C2 if you're not so familiar with Pascal's triangle yet. Okay. My probability for, what is it, 3 boys, 2 girls? 3 boys, 2 girls. 3 boys, 2 girls is going to be equal to, all right, how many ways can I have 3 boys and 2 girls? Excuse me. And the answer is 5C2 or 5C3. It's the same number. Okay. Times what? This is still the same fraction I had before. Why is that? Yeah, that's right. Remember, having a look over here, even though I haven't finished it off, right? Because they've actually told us, this is actually a special case of binomial probability, that each of these is the same. It's half, 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 half. Whichever path you go through, right? Whichever path you end up, like you've got to go through 5 of them, and the probability every time is 1 over 2, right? So whichever one of these branches you end up on out of the 32, it'll still be this chance, right? It's just that there are more branches that lead to that option. Does that make sense? So, what's this number now? We said this was 10, didn't we? So this is 10 over 32, which we can simplify a tiny bit. Okay? Now, part C, have a look. 4 boys and 1 girl. Okay, I'm starting to get the idea here now, right? 4 boys and 1 girl in this situation, same as 4 girls and 1 boy, right? So the probability of what they're asking for, 4 boys, 1 girl. I already have this, right? How many ways are there this can happen? 5C1 or 5C4, same thing. What's the probability of getting any of those branches at the end? It's going to be that. Okay, so this is still going to end up like this. You see how I'm doing this, right? Okay, and this is a very, very simple version. Okay, I'm now going to give you an example where, you know, just like with folding board, right? Each of the events, the 2 options that could happen, they don't have to have the same chance, right? Sometimes one event is much more likely than the other, okay? So what if, for instance, I was like dealing cards and I was interested in, say for instance, all the spades, okay? All the spades. And I said, all right, I'm going to deal a card out, I'm just going to shuffle them, and then I'm going to pull one out at random and say, what's the chance of getting a spade? Right? Well, it's a spade. Okay, there you go, right? Didn't even know. Now, what's the chance of getting a spade on any particular turn? It should be a quarter, right? Because there are 4 suits, so it's 13 on 52. So instead of having something like this, right? I would say one of them is going to be a quarter. The chance of getting any other card will be 3/4, right? Okay. Now, let's just say, for example, I wanted to deal out a poker hand, right? Do you remember how many cards are in a poker hand? It's going to be 5, right? So 1, 2, 3, 4, 5, okay, like that. And what I've got to do to make sure that this is going to fit under binomial probability, right? Think about this. Have I ticked off all of my boxes? 2 options per event? Yes. All I'm interested in is spade or not spade, right? Multi-staged events. Is it multi-staged? Do you think? Is it many-staged? Yeah, it's 5. That's a lot. Is it identical? No. It's not unless I'm pulling out a card and then putting it back, because I need to reset the deck and make it the same thing, right? Does that make sense? Okay. Now you could then work out if I did it that way. Okay. What would be the probability, for example, of getting a flush? A flush means everything the same suit. In spades, what would be the probability? That's going to be simple, right? Right? Yeah. And there's one way of doing that. Yeah. What about if I wanted to get, say, 3 clubs? Sorry, 3 spades. 3 spades. Okay, so you've got each of the spades, right? Each of the spades. But remember, you've got to get other cards as well, right? What's the probability of getting those other cards? It's 1 minus a quarter. It's the complement, right? And how many of those cards do you have to get? 2. Because remember, you've got to follow all the way along to the end of the branches. Now, how many ways are there to do this? Think back to my children, my boys and girls, right? There's going to be 5C, well, either 5C2 or 5C3. They're the same number, aren't they? Okay. So you can see here. Does someone want to go ahead and work out what that number is? Someone? Anyone?
Try faster.
45. Can I have a percentage? Give me one decimal place. 8.8%. Okay. All right. Now, then becomes my question. Okay, what's the most common number of spades to get as I do this? Right. Now, pause for a second. The most common number. That corresponds to the biggest percentage, right? Which is made up of all of these bits and pieces. These are binomial coefficients, right? This is greatest coefficient. Now, I don't know what the number is, but it's not that hard to work out, is it? Because you know how to do greatest coefficients, and here are some numbers that you can choose, right?